introduction and our process.
You need to share your presentation. Thomas, I don't want to interrupt, but just to remember you that.
Thank you.
Yeah.
So, and yeah, I think we will start. We are in new factory in Switzerland. Before we go through the agenda, that is the introduction, the new technology for lithium-ion battery separator and how we produce it. And afterwards, question and answers. So it's a shortly agenda. So, like you told before, Europe is a Swiss startup. We are founded in 2020.
I'm sorry, Thomas. Did you share your screen? Because I think I still see my screen.
Oh, okay. It's not normally as. Wait.
Stop sharing mine. And yes, this I forgot.
Okay.
So yeah, can you try now? I still don't see the screen, but I think it's coming maybe. I start. Okay, good. It's coming. Yeah.
So it's here.
Yeah. And just to remind people, you can to people that they can write their question already in the chat. I will take everything at the end of your presentation. Thank you.
Okay, thank you.
Thank you. Thank you. Okay, so now you see the starting picture. The agenda for this presentation is the introduction, about the new technology for lithium-ion battery separator production, question and answers. So, Europe is a Swiss startup. We founded in 2020 in the east side of the Swiss, also 2 hours almost from Zurich, and we find we find a new solution and the way it developed, how we can produce a foil, a membrane for a lithium-ion battery. That means we know all the ways of the separators of the, what's the critical points? You see it here, it's still the same. It's not only costs and delivery time and ways, it's also the size, the performance by himself, and for which cells, battery cells, you can use it where this is happened. Yeah. And again, and to my person, shortly, I'm coming out of the printing business. I'm an engineer of the printing business in the rotogravure, in the galvanic, offset printing, screen printing, in all directions. I worked also a couple of years in the security printing. This is passports, banknotes, and this high resolution documents. Therefore, it was also in the past the reason why I found out with this how we can do it in a high resolution with an ink on a special material to get pores in a foil. And that's the reason why I started a couple of years ago with some tests, small tests, and this grow up after the time. Every step which I have done, I have to confirm, I have to repeat it for myself how it works. And so in this way, I found out which kind of material I can use, the polyester, which kind of ink, which kind of laser, the frequency, and what we need for this to get all the topics what the separator foil need. Our technology, you will see it now. We create a program for a printing form in the rotogravure with a high resolution. That means we have a resolution of 2 microns, which is very high. We put all the holes directly with a special laser in the printing form. We can do it really linear, and we control every size and every position of the printing dot. You will see it later on the next pictures. We put this on the printing form. Afterwards, we print this with a special ink, which is water-based, on this foil. This is a very thin PET foil. It's only 6 micron, the thickness of this foil. It's only one layer because our system is 2-layer system. You will see it in the next slides as well. And therefore we print it in a rotation speed. This is for rotogravure printing more or less a standard. Only the tools are not standard, they're really special. I also write this program for the laser who makes the printing form. I also developed this special ink, and I put all these components together to get out this printing form as one step. You see it on the right hand side. This is a surface, how it looks on the copper printing form as a dot, a printed dot in this. Afterwards, when it's printed, when it's done, we developed a special laser light line. We call it like this because it's a UV laser. That means in a correct frequency and heating, he activate the carbon in the ink to melt, to make pores in this thin foil. And this you see down on this drawing here. Printed. So the foil come in here. It's the drum, the printing, and here it's coming out, the printing direction. Of course, not only the product by himself is patent, also the whole working process. You see it here, we have it done with drums together. Here you see on the left hand, the printed foil, and on the right hand side, the perforated foil, the almost finished foil of one layer of this 2-layer system. Here is the very first type of the laser light line to test how it works. This is at Trumpf at the factory. And now this is our system, the final machine, one of the final machine for our prototype line, which we produce now. And now I change shortly the presentation to get in more details. So here, left-hand side is the printed foil. You see very accurate printed dots. We got a resolution.
Thomas, can you put presentation mode because we see the
yes,
PowerPoint? Yeah.
You see on the left-hand side the printed foil. There are 4. It's enlarged, but not enough. You have around 5,000 dots per square centimeter. That means a lot of pores on a small area. Of course, the current separator system is, have some smaller pores, but our system together reduce this amount for the liquid to protect this system. On the right hand side, you see this is the machinery with the cooling tower, the rack, and the heart of the machine. This is the laser light line. And through this laser light line, you see here the foil, we put it here on, it's running through, and here get it on finally. That means here it's the printed foil, and here is the poured foil. This is the result after the laser light line. It's running through, and almost every dot is melted, every printed dot is melted. And now I show you again a short movie how it works. So you see the machine is running. And after this, you get this porosity, high porosity foil. After this, we clean it up in a special machine, but it's a water paste cleaning, so it's very clean, green solution. We put it through the drums. That's the reason this brush and the thin foil, it looks like it makes fold, but this here you see, it's straight. This has to do with the thin foil. It's only 6 micron, and it's running in the liquid and going through 2 paths. The first, the rough path, and the second one to clean it really up and to dry it. After this, of course, it's cleaned. We put it in a dryer cupboard for 24 hours at 120 degrees and 100 degrees to get it really dry before we cellophanate the 2 layers together. That means in one side the dendritic filter, and in the other side the membrane, the perforated foil, which we produced. You see it here. This is the dendritic filter. It's a big and large. Also our perforated foil. Let's put it here. We put this on one machine, and with a heat of 60 degrees, we put this with the pressure of 1000 kg together without glue. So there's no glue inside. You see it here from the other side and here from the top side where we put it together. And the final result is, again, I show you another short movie that you see our material. This is the final roll. You see here some that keeps together. That means our perforated foil and the dendritic filter. And you see, if you're stretched, it's a plan, and if you leave it, of course, without pressure, is no tension in this. But this is the final material. And afterwards, we customize this material. And you see it here, the material in the whole width, 20 centimeter, 200 millimeter in the width is our production size. And then we cut it out, customize which size roll the customer need. We do this in one step. So, and that means in the end, all our production, then here again, our material, our system, the heat resistant is up to 175 degrees. Increased really the charging time, the performance, the tension, and the whole density. You see it here again. Is more than there, around 1 to 15 Newton meter. And here to compare to the current reference material, the separator and our separator system is maximum between 15 and 21 micron in the band of the melting edge. And the other one is always a free layer system. Also we say it, the current or one of the market leader of this reference material. So, and here again, the process by himself, printing on a gravure print machine, cutting, laser run, slitting on a size, customize, package and delivery. The characteristics of our material, which we get back from the different labels and factories, is the porosity in percent, the pore size, the thickness of the material, permeability, meltdown, wettability, the contact angle, thermal shutdown, yes, of course it has, and the mechanical strength. Of course, these are all figures of the combination of our 2-layer system. Here you see also, which we get back, it was, the reference was Cellcut, so one of the leading in the market. I don't know from the performance, only from the performance, also from the volume for which they sell, and our system. And you see here, we are really increased the charging and also the decharging immediately between 20 and 100%. it increase it. And we are still thinner with our material. And before we go to the question, I go back to the sorry. I don't know where. Oh, so I have to go back to this presentation where we come out. Sorry for this not professional way. So here again, we're on the charging. Yeah, and that is this charging, you see it here, the 1C, 0.5C, 0.2C, and 0.1, this volume, what you have to charge and decharge. And by the way, it's also, we have also done some tests with different material, which means sodium, or for hydro batteries, it works also our material, it keeps, but therefore we need, of course, professional POC results that we have to do, but it's also in the plan. And yeah, you see it here, it's very well from the charging this. And this we get also from the different labors and factories back, all these results. And yeah, this is from our material, all our process again is patent, also the material is patent. And yeah, this was a shortly introduction for you to see. And did you have any question about all of this material?
Exactly. I open the floor to question. You can write it in the chat or just raise your hand. And I might start with one. So you compare it in terms of performance, right? With this charge and discharge curve. Since you say that actually your membrane can also be safer, did you also try some experiment in which you heat up the cell and try to see until, how does it react, your separator, in order to avoid, I don't know.
Yeah, this information, these results we get also back. The separator by himself is safer because it's more heat resistant, much more than they need. The tension is much higher. And the point of the saving is which kind of cell they are produced. Is it a pouch cell? So there's the reference point, a completely different one compared to a cylinder cell. And the next point is we have sent out a lot of material to different factories and labors. They all will test it, and we get again back a confirmation how it works for these all security parts. But still, it's much more secure, or minimum the same secure what we get now in the current market with separator in the compared to other one, to our one.
So if I understood well, you send your separator to different companies and you will get some result about how...
Yeah, they do it on the test now.
Okay.
This need a couple of weeks or months in the band. All these factories we know all, because this is a small market, is the battery, the cell produce.
Okay. And so it's just conventional cell, or are you also approaching solid state, but no, not solid state, sorry, lithium metal?
Yeah, we have done some different tests with some different material inside, and our separator keeps in all the different material. But for the lithium-ion battery, like it is used on the market now, for the different liquids that they use, it works in all of them.
Okay. There are questions from the public. Are there some questions? So I don't see any question, and
I think everything is clear.
yeah,
That's good.
and but yes, maybe will be nice to see more results about how the separator is applied on current technology and see really how does it overcomes some limitation that yeah nowadays cell have. And also maybe you can just add something about stability. So is it the material stable, right, while cycling? And
the charging and discharging that this test has done, and they stopped with 1,200 runs, charge and discharge, and this in a 1C. That means as in a high one. We also tested shortly, but still we need to confirm about with 2Cs as well. So for all the because the material is really a strong one. It's thin, really thin, and the two layers together, yeah, 20 microns more or less, and it keeps really a lot of heat. Is against yeah acids and this different things, so it's very robust. You know what I mean?
Okay, yeah, looks promising. So yeah, we have Diana. Do you want to say something?
Thomas, the separator has no coating. Maybe you can
Oh yes,
emphasize on why it has no coating and it's not requested.
You know, our separator, all the tests confirmed this, is no without ceramic coating. So, like we send the separator out, our two-layer system, you can use it at once because the wettability, which is important, the surface of the separator, is so good. So we have you have seen in the back, I compare, we have a contact from 39 on the wettability, the value of a 39, and the standard on the market is much higher than 45. So that means the liquid with the ion in the battery can move very slow both our system through our separator system. That's a really good thing, and you save a lot of costs and process and time for this ceramic because we don't have it, and don't do it as well because these pores all will be closed if you try to put ceramic on it. So this works without the coating, this separator. So that means you get a final separator system. When you order it, you get it finally, so you have nothing to do, only we have to know your size which you need in the width. And the maximum, our size is 20 centimeter or 200 millimeters, the maximum width. We can do it smaller, but not wider, because this is in the band, a laser light line, and to guarantee from the left to the right exactly the same pore size. That was really important. If you go bigger and bigger in the right, yeah, you get another production process problems. That's the point.
Okay.
And we drive with a high speed.
We have a question. What's about energy density from Frieder Herb? The energy density that you can achieve in a cell whenever you, with respect to conventional cell, whenever you use your separator, what it is the energy density that you can achieve?
The energy density, yeah. Also we increase it around 25% minimum as minimum. In the band, we can also, I told you before, explained you before, in the band of the size and the amount of the dots on the perforated foil. This has a big influence. So the customer says, okay, I needed a lesser perforated with lesser pores, and or in this case bigger or smaller. So this has a big influence on the energy density. So we are flexible to create for all customers a customized separator. You say it in this way. I think it's easier to understand.
Yeah. Yeah. So if there are no other questions from the public, I think, yeah, the presentation was clear, and I hope that, yeah, the public of this session will contact you in case of needs of customized separator.
Thank you.
Yeah. So good afternoon, and see you the 1st of November. Please inscribe to the annual conference so that we can, yeah, have some networking in presence. And yeah, see you soon and have a good afternoon. Bye.
Okay, thank you. Bye, everybody.
Thank you. Bye-bye.
Bye.
Thank you. Good afternoon.
Bye.
Bye-bye.